Okay, so I'm going to record this so you can go back and look at any of this if you feel like I'm going too fast. But we're going to go a little bit at a time, and we're going to just talk about some of the important things that you really need to remind yourself about before we start the semester. So there's a lot of things in General Chemistry 1, and what we do in Chem 2 is we expand on those. And so I just tried to summarize the ones that were the most important at the beginning, and that's what this sheet is here, the one that says Chem 152, Review of General Chemistry 1 Concepts. Okay, so if you look at the agenda, what I put on the agenda, I did the syllabus, and then I said Chem 152, Review of Chem 1 Concepts. Do not Google to answer each type, formula, or molar mass. I just didn't want you, the purpose of this is not to fill it in. The purpose is remind yourself about when is a substance an element. These are pure substances. When is a substance an element or an acid or ionic compound or covalent compound? And then how do I figure out the formula using what I learned? And then when I get the formula, how do I calculate the molar mass? So I do not want you to Google any of these other than after you figure it out, maybe double check your answer. But if you Google molar mass, you'll get the wrong answer. There were some things I put on the final exam last semester too that I knew if you Googled it, you'd get the wrong answer. So it was kind of obvious when somebody cheated because it was actually like a trick. And I got kind of upset because I saw some, I was like, oh gosh, don't. So just keep that in mind if you are at home and some of the things, I know you can Google them, but you'll get them wrong because most of the things that I put on a test that you take at home, you will get wrong if you do a Google search for it, because Google tells you the wrong answer sometimes. Anyway, so you want to use your Chem 1 notes to review how to write formulas. Use our class periodic table anytime you need molar mass. And all the chemicals in the questions down here are actually the ones that are up top. And so if you go down here, if you don't realize that, you'll be like, oh my gosh, I don't know the formula of hydrobromic acid. Well, yeah, you do, because if you've done the first part, you have the formula for hydrobromic acid. And then down here, you'll need the molar mass of potassium hydroxide. Well, potassium hydroxide is in the top. And if you've done it completely, then you have the molar mass of potassium hydroxide. So everything down here involves chemicals from up here, except for isopropanol. That's the only one, and I give you that formula. So all these questions involve chemicals from up here. Okay, so let's just start with the 3 columns that you want to fill in. So for type of substance, the answers would be element, or it's an acid or ionic compound or covalent compound. So there's those 3 kinds of compounds, or it's an element form. And these are pure substances, not just symbols on the table. So what you want to do is you want to look at the chemical name and figure out, using that name, which category it falls in. Okay, so sulfurous acid should be one of the easier ones. What type of substance is sulfurous acid? It's an acid. And that is not a trick question. Any of the ones that their name says acid, guess what? They're acids. If the name does not say acid, it's not an acid. So don't put down that barium chloride is an acid, because it's not barium chloride acid. Only the ones that say acid in their name are acids. So again, not a trick question. If it's an element, it would actually be an element name. So anything that is just an element name are elements. Okay, so sulfurous acid. The reason you want to figure out that it's an acid is because in order to determine the formula, you've got to go and look back at your rules on, if I have an acid, how do I figure out this formula? So here's what we're going to do. I'm going to give you like a little summary of acids, and then we're going to compare this sulfurous acid, because it's an acid. Okay, there are mainly 3 types of names for acid. So I'm going to use these 3 as an example. Okay, so hydrochloric acid, chloric acid, and chlorous acid. These are the three kinds of names. And kinds means that there's a format. And so what do you think they all have in common? They have two things in common. What two things do they all have in common? They have different kinds of suffixes and the word acid. So they all have some kind of suffix and they're acids. Okay. And they all have which non-hydrogen element in common? Chlorine. But they're not all the same acid. Every acid has its own name. So they're not all HCl. They're all different. So if you look, this one has a prefix, hydro. So if you see a name and it starts with hydro and then something acid, what this means is that you have hydrogen with some kind of ion. Okay. So the hydro means hydrogen, not water. Hydro is hydrogen. They all have hydrogen. Okay. But the hydro indicates that the thing that you see here is an ide. And so if you take this and you put, instead of chlorate, you say chloride. What is chloride? Chloride is just Cl. Okay, so that's chloride, so that's just Cl. And that's a -1. Chloride is Cl -1. So hydrochloric, hydrobromic, hydroiodic, hydrosulfuric, hydrocyanic. They're all hydrogen, and then whatever that other thing is, that ion. And so this is hydrogen and chloride. It's not the formula, right? This right here tells you how many hydrogens it bonds to. So what is this number? 1. So guess how many hydrogens there are? 1. So the formula would be HCl. Everything about the name tells you what, for every single chemical, that name is all the information you need, plus what you've learned. Okay? This one does not have hydro. So doesn't mean there's no hydrogen, it's just there's no hydro prefix. And so what that means is that you have hydrogen bonded to a polyatomic ion that ends in 8. They all have hydrogen. So having no hydro prefix doesn't mean there's no hydrogen. If it immediately starts with chloro, bromo, iodo, if it immediately starts with that, it means that it's a polyatomic ion that hydrogen is bonded to. And so this ick is really the polyatomic 8, which is chlorate. And hydrogen is bonded to that. So if you still have your little cheat sheets from last semester, you might have written down the polyatomic ions on them. You can get those out, or you can go back and find the polyatomic ions and write them down. But you'd look up chlorate, which is ClO3 -1. It's chlorate. How do we know how many hydrogens there are? That right there. How many hydrogens are bonded to it? 1. So it would be HClO3. Thank you. Okay. This one has no hydro. And so that means it's polyatomic. But it's the ite ion. It means that the polyatomic ite ion is bonded to hydrogen. And so chlorus, that's chlorite, with hydrogen on it. So you'd look up what chlorite is. So I'm going to go ahead and just tell you what it is. ClO2, -1. That's that ion. That's how many hydrogens you have bonded to it. So it's HClO2 AQ. Okay, so every acid is one of those three formats. Hydro something means hydrogen with an ide. And so you go look up the ide version, whatever its charge would be, that's how many hydrogens are on it. If it's an ic without a hydro, it means that's the polyatomic ion 8. And all 8s and ites have oxygen. Sulfate, phosphate, phosphite, sulfite, nitrate, nitrite, they all have that element and oxygen. Whatever the charge is normally, that's how many hydrogens are actually covalently bonded. Okay, so here, which format is sulfurous acid? It's the ite. Okay, so this is polyatomic ite. This is version 3. Version 3. Kind of like when I say step 5, that's me. You know, that's my step 5. So version 3 means it's sulfite with hydrogen bonded to it. Does anybody remember what sulfite is? It's sulfur with some oxygens. It's sulfur with 3 oxygens and a -2 charge. It doesn't have a -2. Why did I want to look at -2? That's how many hydrogens are bonded to it. So how many hydrogens are on it? 2. So it would be H2SO3AQ. All of those are things from my semester, and we gave you rules for naming acids. Go back and look, or if you have a name, go the opposite way. If you have a formula, go the whatever way. But they all fit 3 different scenarios. It's either hydrogen with some kind of ide ion, but this is covalent because these are all nonmetals. And so it's not really in the ion form. These hydrogens are bonded to this ion, covalently bonded. Okay. So this is the formula. It's an acid. In order to do molar mass, you have to have the formula. And so now we have the formula, and I want you to use the periodic table for chemistry here so that we all have the same one. And then I know also that you're actually figuring it out and not just Googling it, because figuring it out is the concept. I don't care what the actual answer is. I care that you know how to do it. That's the whole purpose of this. Okay, so you go and you find our table, which everybody should have, and you have hydrogen. And how many hydrogens do we have? We have 2. And remember, I don't want you to round to any decimal. And so every number that you see under hydrogen is what you use. And so that's 1.0079 grams. And then you're going to add it to, and you look up sulfur. And underneath sulfur, it says 32.065 grams. That's the average atomic mass of sulfur. And there are 3 oxygens here. And average atomic weight of oxygen is 15.999 grams. Most of our atomic masses on this table have 5 significant people. Some of them don't, but most of them do. So just whatever number you see, use it all, add it together, and do not round when you're figuring out molar mass. So if you add it up, it's 82.0778, and the units are grams per mole. So remember, if it's a measurement, They have units in molar mass is grams per mole. So it's 82.0778 grams per mole for this substance. Okay. So what I would recommend that you do for this is there's 4 types of substances: elements, acids, ionic, and covalent. Whichever one you're most comfortable with, do it first. Always start with what you know the best. And so if you are understanding the acids right now, then do the acid. How do you recognize the acid? It says acid. If it doesn't say acid, it's not an acid. Okay. If you don't know what ion it is, look up the ion, but don't look up the whole acid name. So hydrobromic, this one, it's hydro and then the ide, and so bromide. If you don't know what bromide is, look up what the ion bromide is. Acetic acid, it doesn't have hydro in front of it, so it's this one. So it's the beginning of that name with an 8. If you don't know what acetate is, look up what the ion is, or look it up or look on your sheet. And that way you know how many atoms of each element there are in the formula and what its charge. The charge, you don't leave the charge on it. The charge tells you how many hydrogens are on it. So how many acidic hydrogens is equal to that charge. The charge of these is due to the extra electrons, but really those electrons are being used to bond to hydrogen. Okay. And then or if you like ionic compounds, do all the ionic. How do you recognize ionic compounds? What do you look for? A metal and then a non-metal or a polyatomic ion. And then you got to use the charges to figure out the ratio. Easiest, I think, are covalent binary compounds, because what you see is what you have. So you see prefixes, and that tells you how many of each thing you have. Okay. Once you get the formula, if you want to double check the formula, double check it online, but don't just do that. Okay. Sometimes if you check it online, you'll get the wrong formula because it'll put it in alphabetical order or something crazy, or it'll distribute the subscript into a polyatomic ion, which we don't do. We put the polyatomic ion and then the subscript on the outside, so it won't make any sense if you try to look it up. Like if you looked up calcium, let's see. Like if you looked at cobalt-3 nitrate, the formula would make no sense to you because it would distribute the subscript to the nitrogen and oxygen and nitrate. So it wouldn't make any sense. Okay. Once you get the formula, then use the periodic table to calculate the molar mass. If you double check it, it will not match online because online is whatever version you might find is the molar mass you'll get. We want the one using our table so that you understand if I have a formula, here's how I do the molar mass. Okay. Okay. So the other thing that we're going to go back and review is how to draw covalent molecules or covalent structures. So covalent is when they're non-metals, non-metal bonds, or metalloid non-metal bonds form covalent. If it is ionic, we're not drawing ionic bonds. This is just for covalent. And so these rules are the same rules that I gave you in Chem 151. And so they should look familiar. But we're going to go through, and we're actually going to draw this acid right here because it is a covalent molecule. Because acids are covalent structures. And so I want to go through, and I just use bulleted points. But if you want to put numbers next to it or label what the bullets mean. Okay, so first, the very first bulleted point, determine the number of electrons available for the molecular ion. That is the first thing you do. So that whole thing is step 1. So out next to that first big bulleted section, you can just say that's step 1. And so we're going to figure out how many valence electrons are in H2SO3. So we're going to do step 1. Okay, so you use the chemical formula and periodic table to figure out valence electrons, not total for all the electrons, but just the ones in the outermost energy level, because those are the ones that can form bonds or are in orbitals as lone pairs. And so you're going to use the periodic table. And so we have hydrogen, sulfur, and oxygen. Okay. So how do we use the periodic table to find valence electrons? Like for hydrogen and sulfur and oxygen, where are we going to find valence electrons easily without having to do electron configurations? Group number. So the group number is the A number. So the group A number, that's the top number, not the period, because the period is the outer energy level, but the group number. And so 1A for hydrogen has one valence electron. So there's two hydrogens, and there's one valence electron each. Okay, and then we have sulfur. There's one sulfur. And we're not doing molar mass. Molar mass is protons and neutrons. This is just electrons, only outer. What group is sulfur in? 6. So it has 6 valence electrons. Okay, and we have 3 oxygens. So 3 oxygens. It's not 30, but 3 oxygens. Okay. Oxygen is a group number 6. It has 6. Each oxygen has 6. Okay, so 2 valence electrons. Hydrogen, 6 total from sulfur, and then 3 times 6 would be 18. So total, we have 26 electrons that we can draw. There are 26 total valence electrons, and we're going to draw all of them systematically. Okay. So the next bulleted point about formal charge is just a little piece of information. It's not a step. It's just a fact, because it's the way that we're going to draw it. We're going to draw things so that they're neutral. And so what it means to be neutral is that when you draw it, the number of bonds and dots that you put on a symbol should equal what its group number is. And so for hydrogen, its group number is 1. So you should only draw a total of 1 bond or 1 dot. Okay. For sulfur, it's a total of 6. So total, you should draw 6 bonds and dots when you add those two numbers together. And dots is in individual dots. And oxygen, a total of 6 bonds and dots when you add the two together, not 6 bonds and 6 dots. Okay. And so before you start figuring out how many bonds and dots, you actually have to put the symbols on paper. So where it says place the atoms on paper, this is step number 2. And literally, I mean, we're going to put the symbols in as individual atoms on paper. So we're going to use symbols for every atom. So we have 2 hydrogens to place on paper, 1 sulfur, and 3 oxygens. And you're not just going to randomly do it. All the little bulleted points underneath it are how to do it. So you got to figure out what goes in the center and what goes on the outside. So to do that, generally the atom with the lowest electronegativity will be the central atom. And that is the atom that is furthest from fluorine. Okay. There are electronegativity tables that you can look at. Or you can do this one. The most common central atoms are carbon, sulfur, phosphorus, nitrogen. If you see one of those elements in that order, whatever goes first in that order is what will be in the center. So does our formula have one of those common central atoms? Yes. What is it? Sulfur. Okay. The other one that's easy is whatever you only have one of. So if there's one of something, it will go in the center. If there's 2 things there's one of, than whatever is on this little list of most common central atoms. Okay, so sulfur is going to be in the center. So go ahead and just put sulfur down. And then you want to read the rest of them. Hydrogen and fluorine are always outer atoms. So hydrogen will go on the outside of this formula. The most electronegative atoms are fluorine, oxygen, nitrogen, and chlorine. So that goes back up to generally the lowest electronegativity. Well, the highest is fluorine, then oxygen, and then nitrogen and chlorine tie for third. See the electronegativity chart in your books. There's an online textbook. You can see that chart. Then the last bullet for oxyacids. Oxyacids. As an acid with kind of element, oxygen. This is an oxyacid. If it's not an oxyacid, this doesn't go with it, but this is an oxyacid. The acidic hydrogens are bonded to what? What does it say there? The acidic hydrogen atoms are single bonded to oxygen. And so these two here, they are bonded to oxygen. So what all those points are telling us, these bulleted points are telling us, is how to place things. And so outer and center is the main point. We have our center. The other ones go on the outside. So how many oxygens do I draw? 3. Okay. And then I got to draw 2 hydrogens. But where do I put the hydrogens? Next to oxygen. So they're not bonded to sulfur. So what that means is the hydrogens don't go on sulfur, they go on oxygen. And so I'm going to put the hydrogens further away. And this step number 2 is not drawing bonds. You're not drawing bonds yet. You're just putting the symbols on paper, and you're trying to create it so that you can start connecting the dots. Okay. The next 2 bulleted points are the information you're going to use to draw it. So this is information. So those points, the know how many bonds, and then the other ones are sulfur, phosphorus, and arsenic. They're not in the table because they don't have a set number of bonds and dots. You just got to add them up to 6 or 5. These are the trends that we use to draw. So the very last set of bulleted points, when drawing molecules, that is step number 3. And so you're going to go from, I got all my symbols on paper, to when drawing molecules, use the bonding rules to correctly create bonds and place lone pairs on each atom in the structure. You're going to start with each outer atom. So you're going to use these bonding trends up here to draw lines and dots. But you don't just start in the middle and work your way out. You actually start on the outside and work your way to the middle. Okay. So that first is just a statement on what you're doing and what you're going to use. Okay. So start with each outer atom. So I'm going to start way on the outside for the hydrogens. So what it means by use the bonding rules is you go up to the table and you find hydrogen. Does everybody find hydrogen? What does it say about bonds and dots for hydrogen? 1 bond. Okay. And so here's hydrogen, and I'm going to draw a bond to connect it to the next atom, which is oxygen. And the reason it's on your paper is because you drew it on your paper. You've got to put them in the right order. And here's hydrogen over here. You're going to draw a line. Okay. Then you go to the oxygens because those are outer atoms. Okay. So you find oxygen in the table, and it says that oxygen needs 2 bonds and 4 dots. You're going to do each oxygen completely before you move on to the next. So which oxygen do you want to do first? One by itself, or one of the ones with the hydrogen? Anybody? Okay, so we'll start here with one by the hydrogen. So I'm choosing this oxygen here. And the rule is I need a total of 2 bonds. This oxygen has how many bonds already? 1. So how many more does it need? 1. So you draw it, don't go backwards because you're done with hydrogen. Once you're done, you can't go back and change anything. And so now the oxygen bonds are done, but now I need to give it 4 dots. The dots should be put in pairs. So the dots always go in pairs unless it's an odd number. That. Yeah, I'm done with that oxygen. So you move to the next one. This one already has 1 bond, so it needs 1 more bond. And how many dots? 4. Okay. And then we have this one here. It doesn't have any bonds yet. How many does it need? 2. But I don't have a hydrogens, and you can't add symbols. And so if you need 2 bonds, you just draw 2 lines like that. And it also needs 4 dots. Okay, so we did all the outer. Once you're done with everything on the outside, you go to the middle. Then add lone pair electrons to the center atom if you need to achieve a formal charge of 0. I'm going to give you 2 options for this last step, and you decide which one you want. And so I'm going to give you option 1, which is what I wrote down. Add lone pairs to the center atom. What element is this? Sulfur. So you find sulfur in the rules. Okay, so sulfur, the number of bonds and dots has to add up to 6. The only thing you can do in the center is add dots. You cannot add bonds. Okay, so how many bonds does sulfur have right now? 4. So it's got 4 bonds. So how many dots does it need? 2. 2 dots. So you go over here and you find an empty place. Don't put them where dots are, where bonds are. Okay. Option number 2, which you might like this option better. How many electrons can I draw? Why did I do this? I can only draw 26 electrons. Okay. So option number 2, instead of going, what's the rule for the middle atom, is when you're done with all the outer atoms and all the bonds, you see what you have. So I have got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I drew 24 electrons. How many am I supposed to draw? 26. Okay. Where do they go? On the middle. When you're done with all the outer atoms and you follow the rules, you can count up how many dots, how many electrons you drew, and compare it to your starting point. And if you're missing any, those dots go on the center. Whichever way makes more sense. When you're done, though, you got to make sure that you drew that many, because that was the whole purpose is I can't draw more than 26 or less. Okay. Okay, so let's draw. I think we have time for 1 or 2 more, and then I gotta show you how to draw a new kind of structure, which are the bondline structure. So we're just going to do simple. These are simple molecules. Simple means there's mainly just one thing in the center, and maybe the most complicated of these would be this kind of acid where hydrogens are on the outside. Okay, so let's draw HCN, which is actually something you all drew last semester. But we'll just kind of, I doubt you remember everything you did. Okay, so the first thing you'll do is you'll determine how many electrons total you have. Okay, hydrogen, how many are on hydrogen? 1. And carbon, 4. And nitrogen, 5. What is 1 plus 4 plus 5? 10. Okay. HCN is really easy because it actually, guess what order it goes in? HCN. But how can you figure that out? Well, you're going to put the atoms on paper. This is not really the atoms on paper because you got to leave space for bonds. So anytime you see 2 symbols next to each other, you got to space them out a little bit so you can at least draw the bond. Okay. Determine the central atom. The most common central atoms are carbon. So guess what goes in the middle? Carbon. So carbon will be in the middle. And guess what's bonded to it? H and N. Okay. So then we skip down to use the bonding rules, start with the outer atoms. What is the bonding rule for the hydrogen outer atom? It is just one bond. And what about nitrogen? 3 bonds. And 2 dots. Okay. 2 options for the center. Go to the center and see if it has the right number of bonds. Carbon wants how many bonds? 4. How many lines are there? 4. Or you can say, I drew 2, 4, 6, 8, 10 electrons. How many more can I draw? None. Is that pretty quick? Okay, let's do another one. CO2. See if you can count electrons. Put the symbols on paper where they should be. Draw the outer atoms correctly, and then check the middle to see if it needs anything. I'm going to draw something over here for the next part. Okay. I want to be sure to have, and we got 15 more minutes, that's good. But I want to go over the new thing that we haven't gone over before. But I got the rules, so I want to go through some of the steps so you can understand what the rules mean. Okay, so we got carbon dioxide here. First thing you do, step 1, is to figure out the electrons, so you know how many total you should have drawn. And so that's carbon, and carbon has 4 valence electrons, so it has a total of 6, but only 4 on the outside. There are 2 oxygens, each of them have 6 valence electrons. So we add those numbers together, and we get a total of 16 electrons, so not a lot of electrons to draw. So these electrons are going to be either as bonds or dots. Everything in pairs. If it's even, it's always going to be in pairs. If it's odd, you'll have 1 odd electron, but you rarely are going to encounter odd numbered substances. Okay, so then you got to put the symbols on paper separately. And so you're not going to put O2, you're going to put 2 O's and 1 carbon. And so you got to determine what's the center and what's the outer. So what's the center? C. It's going to be our center atom. And then you're going to have 2 O's as your outer. So C, O, O. Then you'll use the bonding rules that are there in the middle of your paper, but you're going to start on the outside. Always start on the outside, unless you want a nightmare and a headache. If you start on the outside, it is so much easier and you won't get confused. So, what is the rule for oxygen? 2 bonds and 4 dots. So, draw 2 bonds, and the dots go in pairs, 4 dots. Once you're done completely with one symbol, move on to the other outer. It has the same rule, 2 bonds, 4 dots. When you're done with the outer atoms, your 2 options are look at the center and make sure it has the right number of bonds and you don't need to add dots, or count how many total electrons you drew and see if any dots go in the center. So I drew 2, 4, 6, 8, 10, 12, 14, 16 electrons. I can't draw anymore, so I'm done. Or carbon is in the middle, and carbon wants 4 bonds and no dots. 1, 2, 3, 4. 4 bonds, no dots. Okay. If you look at the back of the page, there is HNO2, SO2, NH3, H2O, Cl2, and then the last, the CH2, CH2OH. That is not one central atom. That actually is CCC. So that would be the last thing you drew if you can draw it. The other ones should be drawn. The first one is an oxyacid. So you use the oxyacid rules. The rest of them are not oxyacids. So there's only one thing in the middle for the rest of them. And then the organic things are not, organic molecules are not typically one thing in the center. It's usually a chain or a ring with chains on it, or 4 fused rings together, like steroids. Okay. So, has anybody ever seen molecules like the ones down here at the bottom? Like, I mean, you might not know it's a molecule, but if you've ever looked at like a pamphlet for medicines, you'll see this like geometric figure. That geometric figure is really a bunch of symbols that aren't shown. They're atoms and bonds. And it is one of the most convenient ways to draw big, complicated molecules without having to draw everything. But when you're in chemistry, it's really kind of important to see what's actually there. Because if I gave you that and I said, what's the molar mass of that? Would you know? No, because you don't even, you go, oh, there's a nitrogen and a chlorine. There's a lot more there than nitrogen and chlorine. Even in organic class, I do not like for people just to draw in this format because you cannot see. And we want to see everything possible so that we don't have to sit there and imagine, especially not when you're first learning chemistry. So, at the top of the second page, when drawing a molecular structure given a bond line structure. So this bond line topic here, this is bond line. So what do you notice in a bond line structure? What do you see a bunch of? Bonds, and they're just shown as lines. But what's missing is a lot of stuff. There's a lot of bonds and a lot of symbols missing. Our goal is to systematically put the elements back in that you don't see. Now, you're not creating them because they're there. They are understood. You don't know them right now. And so you want to see what you're supposed to see. And so what I have below is I have the rules, and you go in that order. Again, order really matters, or else you're going to get the wrong things. And so the very first thing you do, once you copy it down, so I want you to copy this down. Okay. The first thing that you need to understand is every line that you see shows a bond between carbon atoms or other elements as indicated. So other elements indicated, I mean, I see an N, that's nitrogen. And that line right there comes to a chlorine, so that's a bond to a chlorine. What you don't see are carbons. Every line that you see coming from nothing is really coming from a carbon. Okay. If you see 2 lines, guess what? It is a double bond. If you saw 3 lines together, it's a triple bond. So the very first bulleted point is just to kind of understand what you're seeing. So to see it, you're going to start filling it in. You're going to fill in a carbon atom at the end of each line. Okay, so you look for lines that don't have anything on them. There's one. So guess what goes there? A carbon. And so at the end of a line where you don't already see a symbol, so I'm going to put a carbon right there, carbon. And right here, there's an end of a line without anything. And so guess what goes there? Carbon. You also place a carbon at the intersection of any lines. So here's an intersection right here. Now, this is not a point for carbon to sit on. Those are bonds. And so if you have an eraser, I want you to erase the point, and I want you to put a carbon where that point was. And if you're using a pen, then this is what you need to do. You need to draw carbon over the point. Don't have it like it's like barely sitting on top of a mountain or something. Those are bonds that are from the carbon. Okay. Here's an intersection right here. And there's an intersection. If there's already a symbol, you don't put a carbon there. So there's already a nitrogen there, and there's already a chlorine. So every line that you drew, every line segment should now have a symbol at the end of it. So that's what that bulletin, once you've done the fill in a carbon atom at the end of every line, add at each line intersection that does not already have a symbol. Okay. Then for every carbon, you want to bond one hydrogen atom for each missing bond until the total bonds to the carbon are 4. It's so hard to say that with as few words as possible. What is your goal? 4. The goal. Every carbon, you want 4 lines. That's what that means. So you choose one carbon. How many lines are on that carbon right now? 1. What is our goal? 4. Okay, so I have 1. How many hydrogens do I need? 3. For every missing bond, that's how many hydrogens you draw. So I need to draw 3 H's. H, H. Now how many bonds does that carbon have? 4. Move on to the next one. How many bonds does this second carbon have? 3. What's our goal? 4. So how many do I need to draw? Just 1. So you're going to draw a bond to 1 hydrogen. Now, and this is completely new. We didn't do anything like this last semester, so don't be like, I don't remember this. You don't remember because we haven't done it yet. All right. That's not a carbon. This is a carbon. How many lines does this carbon have coming out of it? 3. What is our goal? 4. How many more do we need? 1. That 1 has to be a hydrogen. So don't just randomly give it another bond. The missing bond is not really missing. It's understood. We won't, once you start drawing them in though, you got to draw everything in. Okay. Here's a carbon here. How many bonds does it have? It just has 1. So how many does it need? 3. We're going to draw 3 hydrogens. 1, 2. And we have 1 more carbon. How many bonds does it have already? 2. How many more? Okay. So we have now successfully placed the missing hydrogen. So that little, I know it sounds weird. I'm recording this so you can go back and look at it again. And I also have a video that I found where the person does it the same way. So it's not like I'm showing you something that somebody does a different way. So once your website comes up, yeah. Mm-hmm. Yes. No, it doesn't, because we're not doing geometry. We're just putting them on there. You can, and if you didn't want to do it this way, you could put H3, but that's kind of confusing. And so it's much easier to count that way. Okay. And the last thing you want to do is you want to add lone pairs to oxygens, nitrogens, or halogen, or any other atom that requires electrons. Okay. And so you go back over here and see where it says dots, number of dots. These are things that typically get lone pairs. And so we have a nitrogen. So find nitrogen. In the normal bonding of nitrogen, there are 1, 2, 3 bonds. can't add bonds. You can only add dots. How many dots does it say nitrogen usually has? 2. So what do? We draw 2 dots, a lone pair. Okay. Then we have a halogen. Halogens are those group 7 elements: fluorine, bromine, iodine, chlorine. Here's chlorine. And so I just put halogens. Halogens typically have 1 bond and how many dots? 6. So put it in pairs. So that's 3 pairs. You're going to draw 3 pairs on chlorine. Okay. Once you're to that point, then you will have handled all of the things that weren't carbon, which you do last. You don't draw any extra bonds between elements and carbon. The only thing you're going to do is you're going to draw bonds to hydrogens, because carbons and hydrogens are understood when they're bonded together. But you got to put carbon first. You can't start putting hydrogens. I've seen people not put carbon and then stick a hydrogen right there because they hadn't put all the carbon. So you've got to put every carbon down before you start trying to add hydrogens to it. Okay, so I want you to look down here. How many of the homework questions are bond line structures? 3. If you see a bond line structure, it's a molecule. I've seen people say it was a network. A molecule, it has a defined number of atoms and bonds. And this is the definition right here of it has a beginning and an end. It is a molecule. Okay. There are 3 structures on this page that are bond line. So those 3, you want to use the rules for this. So let's just take a look at the first one. You see there's a line, and there's 2 lines going to an oxygen, and a single line going to an oxygen, and a single line coming out of the oxygen. You see those? What does every line represent? A bond. Okay. 2 lines represent a double bond. And you'll notice that some of the bonds go to nothing. Okay. What goes in the place of the nothing? A carbon. At the end of every line, you put a carbon. And at every intersection where there's not already a symbol, you put a carbon. And so this one should have 1, 2, 3 carbons there. Okay. Then you go back to every individual carbon and you count 4. 1, 2, 3, 4. So however many bonds it already has, and then however many more are hydrogens that you add. Okay. If you look at the one below it, it's a pentagon with 2 ears and a tail. See that? What is at every point of the pentagon? What is that point really? The carbon. What is at the end of the antennas? Carbon. And then the tail is really made up of carbons and hydrogens. Okay. This molecule doesn't have anything but carbon and hydrogen because there's no other symbols. And then over here, there's a hexagon with a tail and then an OH. At every intersection is a carbon, and then you count to 4 and you'll add hydrogens. And the double bonds are kind of hard to see because it's a little bit blurry, but there's a double bond in the tail, and there's also single, double, single, double, single, double around the middle. OH, is OH an element? No, it's 2 elements. O, and you want to move the H away and put a bond between them. And so the H is bonded to oxygen. And so oftentimes we write it as OH, but really it's a covalent bond between those 2 things. Okay? So what I want you to do is I want you to try to follow the rules on the first page to draw some of these simple molecules, and then separately try the bond line. So if you think, I got the bond line, I would recommend before Saturday to try to apply these, because right now, if you feel kind of confident about it, you could go ahead, I can do this, I can do 1 or 2 of these. But go ahead and try to do a few of them. Again, all of them are simple. And then the new ones are these bond lines. I'll send you out an email once